day, welcome to another section of our math tutorials. For this particular lesson video, we are going to solve a typical or we are going to discuss about matrix application in business. But before that, if you are new to the channel, kindly like, share, subscribe. Don't forget to click on the post notification bell. If you have any question or suggestion, kindly write it down in the comment section. So I have this particular question that I wanted to solve together, and I read. An investment analyst manages a portfolio consisting of shares in two telecommunication companies, Armax and Unimac. Currently, the portfolio includes 100 shares of Armax and 200 shares of Unimac, with a combined market value of $420. The analyst decides to reallocate the portfolio by selling 50 shares of Armax and buying 60 additional shares of Unimac. After the transaction, the total market value of the portfolio becomes $402. Based on the provided information, calculate the current market price per share for Armax and Unimac Telecommunication Company. Let's represent Armax by A and Unimac by B. Now, the first paragraph says that the portfolio consists of two shares in a telecommunication company, that's Armax, which we have represented by A, then Unimac, which is B. Currently, the portfolio includes 100 shares of Armax. Now, it says that 100 shares of Armax, the portfolio includes 100 shares of Armax, which is A. Now, we have been represented this by A, then Unimac, of which it includes, or the portfolio includes 200 shares of Unimac, which is B, and give us a combined market value of $420. Now, looking at the second paragraph, the analyst decided to sell 50 shares out from the Armax company, telecommunication company. So we are going to have this. So if the analyst decided to sell 50 out of this 100, we are going to have 100 minus 50 shares from Armax Telecommunication Company. And also, after selling the 50 from Armax, he also then decided to add 60 to the Unimac Telecommunication Company, which then makes it 260. So we are going to have 200 plus 60 equals, then give us a market value of $402. Now, the third paragraph says that based on this particular information, we should use it to calculate the market or the current market price per share. Now, we have gotten our equation 1, which is 100A plus 200B, which equals or gives us a market value of 420. Then, now you could see that we have to, you can do something about this particular term. That's the first, second, and the third term. So, if you subtract 50 from 100, we are going to get 50A, then 260B. So now, our second equation, or the second equation, gives us 50 shares of Armax Telecommunication Company, then 260 shares of Unimac Telecommunication Company, which gives us a combined market value of $402. The third paragraph then says that based on the particular information, calculate the current market price per share for this particular, or for Armax and Unimac Telecommunication Company using matrix inversion. So, for this particular question, we are being restricted to use matrix inversion or inverse of a matrix. We have several other procedures or methods we could have used to solve this particular equation. Example, you can talk of the Cramer's rule, which is also part of matrix, or how do you call it, the substitution method, elimination method. But for this particular one, if you use any other method or procedure, we are going to mark down because we are being restricted to use inverse of a matrix. Now, we have our equation 1, which is 100A plus 200B equals 420. 50A plus 200B equals 402. Now, we have to represent this whole equation in the matrix form, because if you don't represent this equation in the matrix form, you can't solve it. So, we represent it by taking all the coefficient of each, the coefficient of each variable. So, we are going to take the coefficient of A, which is 100, and represent them in a matrix form. After that, we represent all the variables also in a matrix form. So, we have 100, 200, 50, 260. Now, these are the constants that we have. After that, we have also the variables, which is A and B. So we have our variable A, variable B, which A represents the R max, then B represents the U max. Give us a combined market value of 420 and 402 respectively. Now, we have represented this equation, this linear equation in the matrix form. Now, we are asked to find, or we are chasing after what we call what? A and B, that's the market price of each share. Now, if you want to find this, how do you call it, the A and B, in matrix, there is nothing like division of matrix. So with that one, you can't use division. So you represent this matrix, or the matrix containing the constant by x, then the one containing the variables by y, then the total market value by z. So we now have our equation to be x multiplied by multiplied by y equals z. Because we don't, or division is not applicable in matrix, we have to find the inverse of x. So how do you then find the inverse? So the equation now becomes y equals x inverse multiplied by z. The inverse formula is given by 1 over determinant of the matrix we are interested in. That's this whole matrix. So we are going to have 1 over determinant, which is x, times the adjoint of x. So this is the formula for finding for the inverse of a matrix. So the whole equation now becomes y equals inverse, which is 1 over determinant of x, multiplied by multiplied by the adjoint of x. This is the inverse. Also multiplied by z, which is the total market value. So this now becomes the whole equation. From our formula, you know our y to be 420 and 402. Now we don't know our determinant, which is determinant of x and adjoint of x. Already we know that our z is 402 then. So it's now up to us to find the determinant of the matrix x, then adjoint of that same matrix. How then do we find our determinant? We find the determinant by multiplying the leading diagonal, or the principal diagonal, which is 100 and 260. After that, we subtract the leading diagonal or the other diagonal from the principal diagonal. So it goes like this: 100 times 260, which is the principal diagonal, minus the leading diagonal, which is 200 multiplied by 50. Now, there are two, so now let's find this determinant first before we go to the adjoints. So this gives us 201, 2, 3, so 26,000 minus 5, 10, 1, 2, 3. So this gives us 16,000. So our determinant for this particular matrix, which is matrix X, is 16,000. Now after that, you move straight to the finding of the adjoint. So let me write the determinant here, which is 16,000, determinant of X, which is 16,000, so that I don't forget. Now, adjoint of a matrix. Now, there are two ways you can find the adjoint of a matrix. One way is the simple method. That's you are going to interchange the principal diagonal, maintain the leading diagonal, and negate them. Or you can create the minus. After that, you find the cofactors, and also you transpose the cofactor to find your adjoint of the matrix. So, for this particular video, we are not going to use that particular procedure or format. We just go by the normal one. Then in our subsequent video, we are going to talk about how we are going to use the minus and also the cofactors in finding adjoints of a matrix. So going by the simple way, you interchange the principal diagonal, which is 100 and 260. So the 100 becomes 260, then the 260 becomes 100. So we are going to have 260, then 100. After that, you are going to maintain the leading diagonal, which is 250, but we are going to negate them. So we are going to have negative 200 and negative 50. So this now becomes our adjoint of x. So since we know our adjoint and determinant, we just insert them in the equation or the inverse equation. That's our main equation to find our y, which is the current market price of Amax and the current market price of Unimark shares. So they are going to, let me write it here, 260 minus 200 minus 50 and 100. So these are the items that we are going to need in calculating for the current market prices for the particular or for the shares. So we know our y to be A and B. Now we have A, B as our matrix y equals 1 over determinant. We know our determinant to be 16,000. So we have 1 over 16,000 multiplied by 1 over 16,000 multiplied by that, which is 260 minus 200 minus 50, 100. This is the adjoint and this is the determinant. Then we multiply it by our z, this z, which is 420 and 402. That's the combined market value for each equation or for the two portfolios. Now, if you reach this particular part, you can decide to either multiply the 1 over 16,000 by the adjoint, or you multiply the adjoint, which is 260 minus 200 minus 50 and 100 by the 420 and 402. So it all depends on you. So I would like to use the second one, that's multiply this whole thing by the other one. After that, then I multiply it by the 1 over 16,000. So let's do this simple multiplication. So I would like to factor this whole thing first. After that, then talk about the 1 over 16,000. So we have 260 multiplied by 420 plus minus 200 times 402, which is our first one. Then minus 50 multiplied by 420 plus 100 multiplied by 402. 100 multiplied by 402. So if you multiply 260 by 420, we are going to get 109,200, then minus 200 multiplied by 402 also gives us minus or negative 80,400. We go to the second one. Minus 50 multiplied by 420 gives us minus 21,000 plus 402, so 402,000. So we then do our subtraction and addition. 109,200 minus 80,400 gives us 28,800. Then minus 21,000 plus 402,000 also gives us 402. 402. So 40,200. So gives us 19,200. So these are the values that we had. After that, you then multiply the 1 over 16,000. Remember, we are multiplying, or we are dealing with this whole multiplication, or this whole thing. But we first decided to do the one in the bracket first. After that, then we do the one outside. So after dealing with the one in the bracket, we had 28,800 and 19,200. So we then multiplied 1 over 16,000 by the 28,800 and 19,200. And we multiply 1 over the determinant, which is 16,000, by 28,800, which gives us 1.8. So don't forget to be writing your A and B whilst you are going. So 1 over 16,000 by 28,800 gives us 1.8. I always prefer it in decimals prefer the decimals to the fractions. So 1 over 16,000 by 28,800 gives us 1.8. Then 1 over 16,000 multiplied by 19,200 gives us 1.2. Now, remember that during the start of the video, we made this A represents Amax telecommunication company, then B represents the Unimac telecommunication company, and you were asked to find the current market price per share for the two telecommunications company. Now you conclude that the current market price for Amax telecommunication company is $1.8. Remember, we are dealing in dollars, not cedis. So $1.8. Then the current market price for Unimac telecommunication company to Unimac telco is $1.2. Now you are done solving your whole equation. Here are some examples you can try your hands on. And also don't forget to write your answers in the comment section. Thank you for watching. See you another